This is number 37, page 110. Ship maneuvers to within 2,500 meters of an island that is 1,800 meters high, or has a mountain peak that high, and fires a projectile at an enemy ship that's 610 meters on the other side of the peak. If the ship shoots the projectile with an initial velocity at 250 meters per second at an angle 75 degrees, that's what I have drawn here. How close to the enemy ship does the projectile land? So we're going to know, basically we're going to know X final there, and then how close vertically does the projectile come to the peak? In other words, how far over the peak does it go? They got a picture in the book. Lots of numbers here. Looks kind of complicated, but again, we have two equations. X final equals X initial plus V initial X times T. No acceleration in the X direction. That's a constant velocity all the time. And then Y final equals Y initial plus V initial Y times T plus 1/2 GT squared. We're going to do an XY table like we always do for projectile motion, and that's going to be X final equals, we're looking for that in the first part. X initial, of course, equals 0 all the time. V initial X equals, we don't know that yet, T equals. And then Y final, we're going to assume that this ship, even though it's not on the water, it's so close that we're going to go ahead and say that the initial is 0. We know the final is 0 because it lands in the water. So the difference between those two is so small, it's not going to really matter. We're going to make that assumption as far as time goes. We don't know that yet. G is equal to negative 9.81 meters per second squared, and T equals. So if you look on the right hand side, we have enough information with our Y equals to find time. All we need to do is go over here and find our X value for the velocity, because we can never use 250 in those two equations. It's a two-dimensional velocity, not a one-dimensional, and so we have to find an X and a Y. So this Y is going to be hypotenuse, 250 meters per second, times sine of 75 degrees, and that's going to give me, okay, you put that in your calculator, and you're in degree mode, you should get 241 with 3 significant figures meters per second. And then our X velocity is going to be hypotenuse, 250 meters per second, times cosine of 75 degrees, and that equals 64.7 meters per second. So I'm going to put these two in here, 64.7 meters per second, and 241. Now I have enough information to actually plug in, but if you want, okay, so you can put in this equation right here. This is a quadratic equation, so you have to have the quadratic formula, which I remember we have a program called the Quadrat program, so we're going to go in and go to Quadrat and put in Y equals, A equals, so remember this is our A, actually that's not our A, 1/2 of that is our A, 1/2 G, which is negative 4.905, and then this is our B, and this is our C. So if you go put those numbers in, you will get a time of 49.1 seconds. That's the same time here. So for the first part, shot here, it starts here. It goes up, over, and then hits here, and I think there's a ship right here, and this ship, of course, is right here. And there's a peak like right here. And we want to know really how far does it go. Now, if you look at the picture, they have some numbers, but those are for comparison. So if this is 49.1 seconds, we substitute into the X final equation, we get X final equals X initial 0, so it's basically 64.7 meters per second times 49.1 seconds, and that gives us, do that real quick, 64.7 times 4.1, that gives us 3180. When you round off, it gives us 3180. Well, the number they give us here, it is actually, we have to add those numbers together. There's 2500 plus 610, 3111. So the actual number here is 3110 meters. This is how far the projectile goes, so we just subtract 3110 minus this, and we get 70 meters. Now in the book they got 80, and I'm not sure, I don't think I agree with them. I think they use some kind of different weird formula, but doing it the way we do it, we got 70. So they went 70 meters too far to hit the ship. The second part they want to know, and they give us a number here, 1800. Remember, the 1800 is just for comparison's sake. So if the peak, I didn't draw that really well. Here's the peak here. If the peak is 1800 meters high, how high is it right here? And then we'll subtract. Well, to right here is 2500 meters. So that is that's our X final. So there's two parts of this problem. The first part, and the velocities don't change at all. But on the second part, the times change. The time is no longer 49.1. That's how long it takes to get all the way. We want to know how much time does it take to get right here. And I can use my X final as 2,500 meters to find that. And basically that's going to be 2,500 meters equals 64.7 meters per second times time. So I divide those two and I get time equal to, what is that? That's 2,500 divided by 64.7. I think I get 38.6 seconds. So if this is 38.6 seconds, that means this is 38.6 seconds. And now, and I don't know this, I'm looking for this actually, so I'm not using the quadratic equation anymore. There we go. I'm actually going to use just the y equals equation and put all my numbers in to get YF. And once I got, and that'll be YF at 2,500 meters. So in other words, when the projectile is at 2,500 meters, what's X final? Well, I can find the time at 2,500 meters, which is 38.6. Then I just put into my Y equals equation and I get the answer. So that's going to be 241 times 38.6 minus 1/2 G is negative as well, minus 4.905 times 38.6 squared. Press enter and you get 1994, which is 1990 basically. So we get 1990 meters. And when I get 1990 meters, I know this is 1800. So 1800 divided by 1990, and I get 190. So the difference, in other words, the Y final is 1990, and I'm going to subtract 1800 for that to see how high above the mountain peak it is, and I get 190. The book got 210. Again, I'm not sure. I don't agree with them necessarily. 1990 is a good number. 70 meters is a good number. That's how you do number 37. Again, it has a few tricky parts to it because it has all these numbers. But again, we use the XY table, and there's two parts to it. And we have to find our X and Y velocities because we can never use 250 in either of these equations. And remember, whatever the units for the hypotenuse is, that's the units for the two sides of the triangle. So we're never going to say 250 times cosine of 75 to get a distance. It's not a distance, it's a velocity, which in this case is 64.7 meters per second. That's how you do number 37.